Hello and welcome to eMultiSkills video tutorial. In this video tutorial, we will learn what is Postgres all about and its architecture. So the first slide is about the introduction. So what is Postgre and why it is so famous over a period of time? And this is one of the most sought database nowadays. So one of the most important feature of your Postgre database is it is an enterprise class open source relational databases. It can support SQL, which is a structured query language, and JSON, both format for querying, and it is there in for more than 20 years with the community development. If we talk about the usage, it can be used for the data store. You can use it for data warehouse. You can use it for geospatial application. You can use it for analytics. You talk about anything, and it is available. It is good for all the data types, and it is well suited for all the advanced data types. And in terms of the performance, it is good like any other database which is licensed and which is very costly. If we talk about the features, Postgre is having the MVCC architecture, which is multi-version concurrency control. That means, let's say if I have fired a select statement from EMP table at one particular point of time, in a particular row I wanted to fetch, and at that the same time the row has been updated, then there will be some inconsistency if I try to read data. But what happens when such operations happen, there will be a snapshot available of the previous data so that the data don't get messed up. Although this is not the feature which is only available in Postgre, but all the relational databases like Oracle and others, they do have this features inbuilt. And the important thing is this is free of cost. This is open source. And you have the granular access controls. You can give the access to the particular database to the role, or you can give access to the tables, views, or the procedures, triggers, a particular column. You can give the access. So those things you have the granular access control. You have the concept of table spaces, or the other than your default table space, you can create a separate table space. You can keep all your data over there, and that will be useful when you are trying to take the backup. So it is just a logical kind of separation from other databases. There's a feature of asynchronous app or application, which is very good in terms of Postgre. The backup features that is tremendous in Postgre. You have the online backup. What you can do is at one particular point of time, if you wanted to restore your database, you can use the hot backup using uh, PG base backup, wherein something called as the log files, which is known as the write ahead logging, that will be enabled. If you take a backup of your base backup and all the files which are there in val, which is write ahead logging, if you take those backup, you can restore at one particular point of time, and that is useful when you create the standby database or the or application environment. It has the support for the international character set, so that is one of the other important feature. No wonder whatever the size of your database, it is going to support that. And when we talk about the fault tolerance, the write ahead logging features make it perfect suited for any particular disaster recovery when you have to recover your database at one particular point of time. Licensing, this is always bothering the organizations. If you talk about the famous RDBMS, you pay the cost in terms of the codes which you are going to use. Let's say talk about the Oracle, then you have to pay a lot of license cost. And if we are talking about Postgre, there is no license cost. And uh, if you're going to use it on a compute where the number of CPU cores are more, then we always fear of paying more license cost to the proprietor, that is the organization from which we have purchased, let's say the Oracle Corporation. What in case of this Postgre, that if it is open sources, who's going to support it? So there is a dedicated team of contributors and those who continuously work on it. If there are any bugs, they are fixed, and the new versions are released over a period of time. So licensing, it is open source, and you have the code. You can use it, and you can use it any way you want it to. If we talk about the history of the Postgre, so PostgreSQL project was initially launched by Michael Stonebreaker at Berkeley University, which is University of California, I believe. And the original name was Postgre, which refers to the older version of the Ingress database, which was famous at one point of time. And I believe this project was kicked off in 1985, and after 10 years of development, this project was renamed to PostgreSQL because of its support for the structured query language. So who supports or who works on the development of this product? If there are any bugs or fixes, who does all so this is done by the PostgreSQL global development team. If we talk about the language support, that is awesome. It has support for Python, Java, Perl, .NET, Ruby, uh, C++, and ODBC. Everything is there. Let's talk about the architecture of Postgre. So it is a client server model. So the client sends a request to the Postgre environment. So Postgre, we have something called as memory parameters. So we have memory in the center. Then we have outside we have the background processes. So the main process when the server starts, there is something called as postmaster. So when an application when there is a request from the client, it comes directly to the postmaster. The postmaster will check if it has the all the required permissions to log in into the database. If it passes that, then there is a Postgre process spawned, and then the actual work begins. So let's say a select statement has been fired, and that is stored in the data file. Then first of all, those values come to the shared buffer, and the Postgre is going to read it from there, and then the value is returned back to the client. So the application connects to the the postmaster process. The postmaster checks the application right, and if it is successful, then it connects the client application. The instance doesn't write or read the application directly to the data files. It puts it there in the shared buffer. And the PostgreSQL process acts on shared buffer and val buffers. Val buffers is if let's say some data modification has happened, then this particular buffer area will be dirty, and using the write ahead log background process, those will be returned to the val files, which are kind of log files wherein all the information will be returned, and then that piece of information will be permanently saved to the data files when there is a commit. So it is awesome in terms of the kind of work it does. Then there is a checkpointer process as well, which checks checkpoints, and at one particular point of time, your database will be in consistent mode, so that the data in the data files and memory that will be flushed to the data files. So this is just a basic. So we have the memory area, we have shared buffer, wherein the red value of from the data files are there. Then you have wall buffers, wherein any data which is supposed to be, which is changed, it has to come into this area, and using the wall, it is returned to the data files. Then you have work memory and maintenance work memory. If you have enabled the archiver, then the wall files are moved to the archived wall files. So this is just the same diagram. So we have the post master process, which is the main process. Then we have Postgres process. Then these are the some of the important memory areas: shared buffer, wall buffer, work memory, maintenance work memory, and then you have some of the important, very important background writer, which writes the dirty buffer to the data files. Wall background process, what it does, it picks up uh, the uh, the the changed value from wall buffers and write it to the wall files. If you have enabled the archiving, then it will be finally returned to the archived wall files. Uh, the next one, it is just a description of the different. So when you say systemctl status and PostgreSQL, then it displays you these processes. We'll see it on the demo. So the first process, which is spawned after the postmaster, is the logger. So what it does, it writes the error log file to the log file. Then we have the checkpointer. When a checkpoint happens, so there are some predefined interval wherein the checkpoint happens, and all the dirty buffers, the data which has changed, it is returned to the data files. Then you have writer. Writer again, this is the background writer, which it periodically writes the dirty buffers to a file. Otherwise, the checkpoint happens. Then you have the wall writer, which is a background process which picks up the information from the val buffers and write to the val files. Then you have one of the very good feature, which is called as auto vacuum launcher. So it is kind of releasing the unused space when there are a lot of inserts, update and deletes, and a lot of space has been released in the tables. Then it does a maintenance work on that. So we'll have a separate discussion on that. Then we have archiver. So when you have the wall enabled, so write ahead logging enabled, and you wanted to keep all the transaction logs, so you have to enable this so that you can safely recover your database at a one particular point of time. Then you have a stats collector. Uh, it will tell you about the table usage, statistical information. So these are the background processes which are spawned when you start your uh, Postgre instance. Memory area, you have shared memory wherein database caching and the transaction log caching happens. Then you have shared buffer. So this term you can see in almost all the versions, all the engines of the database. So what it does, it minimizes the disk I/O, and what it does, it puts all the bigger tables into the buffer, and it minimizes the access time when it has to pick the data from the data file. So puts it into the shared buffer. Then you have the wall buffers. What it does, it temporarily store changes to the database, and when it has to write to the wall files, the wall background process picks it up from the wall buffers and write it to wall. It is useful for backup and recovery. Then you have the postmaster process. So what is the postmaster process? The postmaster process is the first process which is started when you start your PostgreSQL instance, and it performs the recovery. It initializes the memory area. It runs the background processes, and the last, which is last but not the least, which is your work memory space, maintenance, work memory, and temporary buffers. These are the different memory areas which are used for sorting. So when you say work memory space, this is used for sorting and temporary bitmap operations and hash join. So the default value is 4 MB, and maintenance work memory if you have the auto vacuum enabled. So and this is used for mainly for your create index and vacuuming. Temporary buffer, this is used for the temporary tables in case you use the temporary tables. And that's it. So we'll see a very small demo which says systemctl status. So let me fire this. Systems ctl status PostgreSQL 12. So when you fire this, you will say that the status is running, and you will see this all this. So you have the process ID. The main PID is 11115 postmaster, and this is what we had spoken about in the architecture. This is the first process, background process, which starts, and then the other processes are started. Logger, which logs all the error message file in error log. Then you have the checkpointer. Then you have background writer, which writes the dirty buffers. Then you have wall writer, which picks up the information from wall buffer and write it to wall files. Then you have auto vacuum launcher. It writes it does the auto vacuuming work, like when you there is a create index happening, or when it has to release the space, unused space in a table. Then you have the stats collector, and then you have logical replication launcher. So this is basic of the architecture of your uh, of your Postgre environment, and we'll quickly do a recap of what we have done. So we talked about the introduction of Postgre environment, why this is so famous. Then we talked about different features. We talked about the licensing, which is free, open source. Then history of Postgre. Then the architecture, memory architecture, background processes, and different physical data files where it is written. And then we discussed about how the data is flown when a client requests the information, and the, the definition of different background processes, and memory areas, and the work memory area related components, and that's all. Then we checked the system CTL status PostgreSQL 12. Then we saw different background processes. Then we saw one more thing. You can see the PS3-P1115. So this shows like what is the relationship. So postmaster is the base. From here, rest of the background processes are spawned. And if you see 1271, it corresponds to the logger. I hope this is going to help, and thanks for watching.